Hello, and welcome to Cloud Computing for Enterprises, Week 3, Virtualization Technologies. In this week's lesson, you will learn an overview of virtualization, including what is virtualization and why is it used. You'll also explore virtualization technologies. Next, we'll move on to virtualization in the cloud. This consists of data center infrastructure, cloud compute, cloud storage, software-defined networking, and software-defined data center. First, we're going to start with an overview of virtualization. What is virtualization and why is it used? Virtualization allows emulation of other computers or devices. It enables us to have software-defined environments, and it enables the technology of the cloud. It can also be programmatically created and controlled, which is much more difficult to do on physical hardware. Cloud computing platforms also utilize virtualization technologies to carve up large pools of hardware into smaller chunks, which can be more efficiently allocated and used by end users. It's not a new technique. It's been around for a long time, since the 1960s, but it's evolved to a standard today where we use it for client-server applications, where we have large pieces of physical hardware, and we divide those up into smaller virtual chunks for different applications and different services. It consists of a couple of different areas. The hypervisor, which is illustrated here in this diagram, is a layer that sits on top of the physical server, and it can substitute for the operating system of the actual physical server, or it can actually run on top of the host operating system that runs on the server. So for example, if that server were running Windows, then we could run a hypervisor on top of that and then run virtual machines inside of that. If the server were running Linux, we could do the same thing and run virtualization on top of that. You can also run it directly on the system. So VMware has a technology that sits directly on the computer server, is the hypervisor, and there is no other OS in the system. And then you install your virtual machines on top of it. And in this diagram, we can see that we have several types of virtual machines running different operating systems coexisting on this server. We have Linux, a couple of instances, we have Windows, and we have Solaris. So as we discussed a second ago, we're going to talk about an exploration of virtualization technologies now. So hypervisors, as I mentioned, those run directly on the server hardware instead of a normal OS, or you can run it on top of an existing OS. Virtual machines, or VMs, these are emulated machines running on a hypervisor. And there are a number of examples of these. On the open source side, you have Linux KVM, you have Xen, you have VirtualBox, and you have Docker. And on the commercial side, you have VMware, Hyper-V, Solaris Containers, and Docker. And there is an optional lab available this week. And in it, you are able to optionally set up VirtualBox on your computer. And then you can either create a VM from scratch, or the instructions will walk you through downloading one from a developer site and setting that up with OpenStack, and then that would allow you to do some private cloud virtualization. So next we're going to talk about virtualization in the cloud. And this is a key enabling technology, as I mentioned previously. So first we're going to talk about data center infrastructure. And here we have two diagrams, and what I'm illustrating is a traditional IT on-premise data center on the left and a cloud data center on the right. And in a traditional IT on-premise data center, your organization is responsible for all of these areas. So the power, the cooling, the physical space, the compute, the storage, the networking, and the applications. That's a traditional data center. In the cloud provider is responsible for all of the data center infrastructure. So the real estate, the power, the cooling, the compute, the storage, and the network. Now, depending on the service delivery model that you actually utilize, as we discussed in the previous week, if it's an IaaS solution, then the provider is not responsible for the applications. However, if it's a PaaS or a SaaS solution, then the provider could be responsible for the applications. So this diagram is making an assumption that you are in an IaaS environment, but if you are in a PaaS environment or a SaaS environment, this blue area that's highlighted as application, that may not be the cloud consumer's responsibility. That might actually be the provider's responsibility. So next, we're going to talk about cloud compute. So cloud compute is just the server resources where an application's workload may run. So this could be virtualized, It could be containers, which is just a form of virtualization, or it could be bare metal. In addition, it may span many physical devices or locations, and it can be provisioned programmatically. So as we see in this diagram here, you want to request some cloud compute. So you go through the internet to the provider's self-service portal, you provision a computing instance, and you may not necessarily know whether it's going on a bare metal server, a container, or a VM. Now you might. Your provider may give you the option to select what you want to move on, but the point is that it is a logical instance and it can be actually tied to any type of physical backend. Next, let's talk about cloud storage. So data is stored in logical storage pools. And this may be a little different if you're used to thinking about your IT department running its own storage servers, its own SAN, its own NAS. These storage devices are logical, and they can be consisting of physical resources within the same facility. They could be spanning the globe. You just really don't know, and you have no control over where the data is stored. Now, as we get into compliance issues later on in the course, we will talk a little bit about where data might be stored in the cloud. So let's look at this diagram here. So the diagram has an individual making a request through the internet to an application. Now that application actually is writing to two different logical storage pools, and those logical storage pools are actually tied to physical storage across multiple locations, as depicted here. So logical storage pool number 1 has physical storage in San Francisco and Austin, and logical storage pool number 2 has physical storage in Austin and Baltimore. And the user is just completely unaware of that. Next, we're going to talk about software-defined networking. So in software-defined networking, we're going to be using techniques to create abstract interfaces to the networking protocols and the hardware devices. And what this means is this enables you to programmatically create and control the network. It's very flexible. And so I've got a diagram here that sort of illustrates how this works. So if you're familiar with IT and networking in general, in the past, you've had to build out physical devices. Anytime you want to make a change to your network, you actually have to go into those devices, make a configuration. You might have to move cables around. The whole idea behind software-defined networking is to be able to do all of this in a virtual manner with software in an automated fashion. And this allows us to be much more rapid at responding to the business's needs than we could if we were to do this with physical hardware. So in this example, the networking layer has been broken up into 3 different layers. At the bottom, we have the programmable switches. That's the infrastructure layer. And those are the physical devices. There's an API between those switches and a network controller, which is the control layer. We make our changes in the control layer. And then there are applications, or there are virtual hosts, or there are physical hosts, and that's our application layer. That application layer talks to a different API to the control layer to make changes or route traffic down through the infrastructure layer, again, using APIs. So if, say, this mail application here, represented by the little mail icon, let's just say that is talking through the network, and we've added a new office to our environment, and we want to be able to have people send email and be able to send it out through that office or something. We don't need to go and set up new physical hardware. We can make changes to the configuration to allow that data transfer to be able to make it through to that other office. So we have that ability to do that at this layer with software, and we can even automate that. And a useful feature for that sort of thing with an application is, let's just say we have an application. Let's just say it's a web application. And we want to be able to talk to perhaps a partner system that's in a completely different environment. Or we make an acquisition of another company. We have that ability to do the network changes that are required for that application to talk to another application, all through software. We don't have to go out and recable anything. We don't have to go out and reconfigure our switches or our routers. So this is very convenient. Next, we'll talk a little bit about the software-defined data center. And so a software-defined data center is effectively just a pool of resources that can be provisioned, configured, and discovered dynamically based on workload requirements. The data center resources are available as a service. It's very flexible and fast, and this enables automation. So we briefly talked about traditional on-premise models in week 2 and how these require that organizations build and operate the data center, the hardware, and the software themselves. So let's just say I had a new service in IT that I wanted to deploy to my environment. In a traditional environment, I would have to design it. I would have to then go request and get budget approval. I would have to then procure and deliver the equipment and the telecom lines, and that can take a significant amount of time. Then I would have to build out or expand the physical plant, which would be the power, the cooling, and the data center space. That again can take many months. Then I have to install and configure the server, storage, and network equipment. That can take a lot of time. Then I have to install and configure just basic software to get the systems running. I have to validate everything. Then I have to go and install the services and configure them. I have to go test them. And finally, I can go live into production. And in a physical data center environment, this requires human action. This requires a long time, and this can take many months, weeks, or in some cases days, but most likely weeks or months to complete. Software-defined data centers, on the other hand, give us the ability to deploy a new service with a lot of flexibility, and we can do it in a very short time frame. So all of those steps above, we don't have to go through if our data centers are software-defined. We can actually automate them. So a human would have to go and request and obtain budget approval. Once that approval is obtained, you just provision your services in that data center. And because it's done through software, you can either do that automatically with programming. You can set it up where you've got a program that automatically provisions that for you. Or you can have a human being go out and through software provision those devices. You do your service testing and you're live. So you can do it in a matter of hours or days as opposed to weeks or months. So in summary, this week you learned about an overview of virtualization. We talked about a virtualization and why is it used. We talked about an exploration of virtualization technologies. Then we moved into virtualization in the cloud. We talked about data center infrastructure and we compared on-premise versus the cloud. We talked about cloud compute. We talked about cloud storage. We talked about software-defined networking, and we discussed software-defined data centers. Thank you and good luck.